Good day, everyone. Welcome back to our discussion on printed circuit boards PCBs. These are essential components in modern electronics, providing structural support and enabling electrical connectivity for efficient device functionality. Introduction to PCB types. Today, we'll examine the various types of PCBs, each designed to meet specific application requirements. From single-layer boards to complex multi-layer designs, we'll explore their characteristics and applications. Classification by layers. Let's begin with classification by layers. The number of layers in a PCB determines its complexity and functionality. Single-sided PCB. Single-sided PCBs are the simplest type, with copper traces on only one side of the substrate. Their straightforward design makes them cost-effective and suitable for basic devices such as charger adapter and more. Double-sided PCB. Double-sided PCBs have copper traces on both sides, allowing components to be mounted on both surfaces. This design supports higher component density than compared to single-sided PCB and is commonly used in audio amplifiers. Multi-layer PCB. Multi-layer PCBs consist of multiple copper layers separated by insulating materials. These are used in high-performance devices like laptops, where space and functionality are critical. Classification by materials. Material selection significantly affects a PCB's performance and application. Flexible PCB. Flexible PCBs are made from materials like polyimide, enabling them to bend and fit into compact spaces. They are commonly used in medical devices. Rigid PCB. Rigid PCBs are constructed from solid materials such as fiberglass, providing durability and structural integrity. These are ideal for automotive applications. Rigid flex PCB. Rigid flex PCBs combine rigid and flexible sections in a single board. This hybrid design is utilized in applications like smartwatches, where flexibility and reliability are essential. Classification by technology. Manufacturing technology also influences PCB performance. Through-hole technology. Through-hole technology involves inserting component leads into drilled holes soldered on the opposite side. This method provides strong mechanical connections and efficient heat dissipation, making it suitable for industrial equipment and high-power applications. Surface mount technology. Surface mount technology mounts components directly onto the PCB surface without drilled holes. This method enables compact, high-density designs and is widely used in automated mass production. Comparison. Through-hole technology offers superior mechanical strength, while surface mount technology is preferred for compact and high-performance designs. Special types of PCBs. Some PCBs are designed for specific applications. High-frequency PCB. High-frequency PCBs are optimized to minimize signal loss, making them suitable for RF amplifiers, communication systems, and radar applications. Aluminum PCB. Aluminum PCBs use a metal core to dissipate heat effectively, ideal for high-power applications such as LED lighting and so on. PCB Types Overview. Each PCB type is tailored for specific requirements, whether for basic functionality or advanced performance. Understanding the distinctions in layers, materials, and technologies is critical for selecting the appropriate PCB for a given application. Wait for the next video, where we'll delve into layer stackup and material properties in PCB manufacturing. Stay tuned for the link once it's live. Also, to know more about us, check out our playlist.